Today's video will be covering function notation, and we will talk about evaluating functions. So this shouldn't be too long. I'm hoping there's a few examples that I want to look at. So I'm hoping that it won't be too long, but this is like the second part of this first unit, which is unit 2. So first of all, let's just start with function notation. So equations that represent functions are often written in function notation. Function notation is just another way of saying f of x equal to 2x plus 7. It's just another way of writing this y. Or it could be another way to write a variable. It's just a function notation. It's just kind of like it sounds. So in this, x is the input and f of x is the output. Similar to how if you're looking at ordered pairs, x is the input and y is the output. Now we're saying that f of x is the function notation for that. That's the output. So function notation is used for finding values that correspond with that. So say, for instance, we know what x is. We can then plug in that x to our f of x, and it'll plug into the original or to the equation that represents. So in this instance, we have f of negative 3. So basically, that just means that negative 3 plugs into where x is. So if we want to find f of negative 3, that means wherever we see an x, we put a negative 3, and we keep everything the same. So then that would end up being 2 times negative 3, which is negative 6, plus 7. That's going to be a positive 1, so that would be our answer. So that's basically it. It's pretty, evaluating functions, it's pretty straightforward. So let's go ahead and look at some examples. So we've got f of x is negative 5x minus 14, and we've also got a g of x. So for the first problem, we're going to look at number 1. F of negative 9. That just means wherever we see an x, we're going to put a negative 9 there. That's all that means. So since it's f of that negative 9, we're going to use the formula, or not the formula, the equation that corresponds with f of x. So we're just going to plug in that equation, and instead of writing in x, we're going to write in our negative 9. That's all we do. And then we just evaluate. So that's negative 5 times negative 9. That's 45 minus 14, which equals, what is that? That would be 31. 31. So f of negative 9 equals 31. That's how you would write that. I'm going to let you do this and the rest of these. I'm going to show you 3 and 5. So let's do one where there's a g. So g does nothing but change this equation, or tell us that we're using that equation now. So we're going to plug in, wherever we see an x, we're going to plug in this 0.4. So we've got negative, and then you plug in 0.4 and keep your negative sign outside of that 0.4. So that's going to be squared plus 9 times 0.4 minus 1. That will give us negative 0.16 plus 3.6 minus 1. Plug that on your calculator, you will get 2.44. So that just means that this g of 4 equals 2.44. Okay, and then the last thing I really want to show you with these problems is when you have a problem like this. So like number 5, it says f of 1 minus f of negative 4. The easiest way to do these is to just figure out what this f of 1 is, figure out what this f of negative 4 is, which just means we're going to plug in 1 for f of x, and then we're going to plug in negative 4 for f of x. So just separate them and then subtract them at the end. So first thing let's do is find f of 1. So we plug that into our f of x equation. So if wherever we see an x in this equation, we're going to replace it with 1. So that'd be negative 5 minus 14. So that's going to give me negative 19. So f of 1 is negative 19. You could just mark it off just to show you're doing two separate ones. You'll probably have more room than I do. So f of negative 4 is going to be the same thing. Wherever I see an x, I'm putting negative 4 now for this f of x equation. So that's what it would look like. That's going to be negative 5 times negative 4, which is 20 minus 14. That's going to be 6. So then I take, this was f of negative 4, 6 was, and negative 19 was f of 1. So all I'm going to do, and I'll write it over to the side, all I'm going to do is take negative 19 minus 6 equals negative 25, and that's my answer for that problem. So the best way to do is just break it up into pieces and do the first part, second part, subtract them. I'm going to let you do all of these, same type of examples. Now you also will get instances where you know what this f of x equals, and all you have to do when it gives you that, so in this it says if f of x equals 34, what's x? All you have to do is replace 34 with that f of x and solve the equation. So don't get confused or overwhelmed by that. It simply means plug in 34 or whatever that number is equal to that equation and solve for it. That's why we did solving equations. So you're going to subtract both sides by 19. Actually, that won't cancel out. That's 34 minus 19, which equals, that'd be what, 15? 15 equals 3x. So that comes down. Now I'll finish it over here. So 15 equals 3x. We got to divide by 3 on both sides. So 5 equal to x. So that's how you would do that. So when presented with what f of x is or g of x, you just replace that and set it equal to the equation and solve for it. And then you may have an instance where it gives you something to replace that x with, but that number still has a variable. So in that case, you're just going to solve, you're just going to simplify it as much as you can. So let's look at 16. We've got f of c plus 2. So that just means wherever you see an x, it now becomes c plus 2. So that's going to look like negative 4. We put c plus 2 in for x plus 9. That's all you've got to do. So if we distribute that, that's a negative 4c minus 8 plus 9. And then that will give us, these are like terms, so that'll give us negative 4c plus 1. That's our final answer. So those aren't super complicated. You just, even if it's more than one term, you just plug it in, and I suggest you put a parentheses around it. So all we did right here was sub in this c plus 2 wherever x was in that equation. And then the final thing I want you to look at is when they have they have multiple terms for you to plug in, and then you have to subtract them. But this is just a more advanced version of doing number 5. So you do it the same way. You're going to work out this g of 2m plus 1 first. Then you're going to work out this 3m minus, or f of 3m minus 1 first, or second, and then just subtract them. So that would look like this. So if we want to plug in g of that, that means we have to plug in 2m plus 1 wherever we see an x here. So that is going to be 2m plus 1 subbed in for x squared minus 5. So then the way you would solve this, anytime you have something like that squared, it just means you repeat it. So you just duplicate it, and then you're going to have to full that out. So if we need to go over some full methods again, we will. But this ends up coming out to, let's see, that'd be 4m squared plus 2m plus 2m, and then that would be plus 1, I believe. Yeah. Okay, so then if we want to work that out, these are like terms, so that's just going to be 4m squared plus 4m plus 1, and then that will go right here. So let me move that over there real quick. So all I did was just work this part out right here just so you could see it. 4m squared plus 4m plus 1. Then we bring down our minus 5. So then those are like terms. So then this becomes 4m squared plus 4m minus 4. So that is what g of 2m plus 1 is. Now we have to go back and we have to do, let me get my colors right. Now we have to do this part, then we're going to subtract them. So f of 3m minus 7, so that means we just plug in 3m minus 7 wherever we see an x in this equation. So that will be negative 4 times that x, so that's going to be subbed in. That x is going to be replaced with 3m minus 7. And then on the end, we have plus 9. This one's a bit easier. We just distribute this negative 4. So that'd be negative 12m. Negative 4 times a negative 7 is positive 35 plus 9. And then these two are like terms, so it's going to be negative 12m plus, what would that be, 44? Oh, wait, I said 35. Hold on. This would not be 35. This would be 28. There we go. All right, so now that would be 37. So let me try to clear some of this out so you can see. So pause and write this down if you can't see it, because I'm about to erase it so that I can add these two together. All right, so for this g2m plus 1, I got 4m squared plus 4m minus 4, I believe. Yep. And I'm going to take that and I'm going to subtract it by negative 12m, because that's what I got for this f of 3m minus 7. I'm going to subtract it by that. And when I subtract it by that, I have to make sure that I put that in parentheses, because this negative sign will distribute to these two, which will end up making it plus 12m minus 37. So now all I have to do is combine like terms. So I've got a 12m here, I've got a 4m, I can combine those. And then I've got this minus 37, this minus 4, and I can combine those. So all of that combined will give me 4m squared. 12m plus 4m is plus 16m. And then negative 4 minus 37 would be minus 41. So that would be my complete answer. And that's a little bit longer of a problem, but that's how you set it up. All you've got to do is make sure that you solve for this first. So find out what that g of whatever that value is, then the f part or the second part, and then just subtract those answers. And we'll work more examples of this in class, but that will be it for this part 2 video.